In this packet, you're going to find some different types of questions that keep reoccurring on Regents exams. So for the first type of question here, it's using the sine and cosine complements theorem. So what you need to know about the sine and cosine complements theorem is that sine and cosine are equal whenever the angles add to 90. So if you see a situation like this where you have sine and cosine equal, well, that means that these angles must add to 90, or vice versa. So these angles right here are complementary. They add to 90 because if you actually add them, if you do x plus 90 minus x, what happens is the x's cancel and you get 90. So that shows you that they really do add to 90. So that means these angles are complementary because they add to 90. So then to explain the problem here, why is this true? Well, it's true because the complements theorem. So by the complements theorem, sine and cosine of complementary angles are equal. So meaning sine and cosine will always be equal if the angles add to 90. So that's what you have to know. Sometimes you might have to find one of the angles, like they might give you sine of 60 and you have to know cosine of what equals that. So you would just look for what angles add to 90. So that's all you have to remember for it. The next type of question is the partitioning question when you partition a segment. So this is something that keeps coming up on exams. So for this one, you can do it graphically. The only caution is what happens when the change between the x's or the change between the y's is going to be a decimal. So I really want you to be able to do it algebraically. So what I always want you to do is draw out this picture first. So we have 2 to 3. So that means that there's going to be 5 parts. So what that means is I'm going to start at point A, and then there's 2 parts. So one section and then another section. So there's the first thing, 2 parts. So it's 2 sections. That's where point P would go. And then there's 3 sections until you get to point B. So here's your 3 sections. So then what that means is in between coordinates A and B, there's 1, 2, 3, 4 points. Always one last point, then there are parts. So what you can do now is you line up the coordinates. So we have -6, -5. We're going to have another coordinate. The second coordinate's the one I want. That's going to be point P. Third coordinate, fourth coordinate, and then your last one here is point B. So 4, 0. So then what you do is you ask yourself, how did I get from the x value of A to the x value of B? So from -6 to 4, you would have had to add 10. You can always put this on a number line if you need to count it out. So if the change is 10 for the whole thing, but we have 5 little sections now that we need to figure out. So really the 5 sections are the distance between the points. So you divide that by the 5 parts. That means you're going to be adding 2 each time. So plus 2, so you get -4, plus 2, -2, add 2 again, you get 0, add 2 again, you get 2, and then you add it again. It should take you back to that point. Then we look at the next side, the y values. So from -5 to 0, you had to add 5. So take the 5 and split it up evenly between the 5 parts, which means you got to add 1 each time. So plus 1, so that's going to get me -4. Add 1 again, that's going to get you -3. Add 1 again, -2. Add 1 again, you get -1. Add 1 again, and you get 0. So the answer here is state the coordinates of P. So P is this coordinate right here. So off to the side, I'm just going to write P and then comma, or -2, comma, -3. Make sure you have those parentheses, otherwise you will only get half credit on this question if it's a 2-point question. So you want to make sure that you remember to put your parentheses. The next type of question that comes up, either usually in multiple choice, but it could be a short answer question, is finding the center and radius of a circle by completing the square. So if you notice, it says state the coordinates of the center and the radius, and here's your equation. So the first thing you do is you regroup everything, you rearrange this. So you're going to group your x's together, and I'm going to leave a box here for the number that I'm going to use to complete the square. Then I'm going to have my y values that I'm going to group together. And then that number is going to go to the other side. So I have to make this plus 11 to move it to the other side. So it's going to be 11 on the other side, plus the box, or plus the square, and then plus the triangle. So that's just the setup. Now you actually complete the square. So for each trinomial here, you're going to complete the square. So I have x and x. You're going to split that up. So what times what gives me x squared. And then for this term, you just look at the number. So you divide that by 2. So that means it's going to be plus 1 and plus 1. And then you multiply to fill in the square. So 1 times 1 is 1. So that's going to go here as well as on this side. So remember that these are the factors of this trinomial. So x plus 1 times x plus 1 equals x squared plus 2x plus 1. And then we do the same thing over here for the y values. So we have y and y. Divide that -4 by 2, so you get -2. Multiply, you always have a positive number here because it's always going to be the same sign. So 4 and 4. So now what I do is I rewrite my trinomial as a product of the square, of the product of its factors. So it's going to be, so I'm rewriting this, so it's going to be x plus 1 quantity squared plus, and then you do your y's, so y minus 2 quantity squared equals, and then you add these up, so I add those up and I get 16. So here, so I just combine those. So here's the equation of my circle and center radius form. Notice that it looks like Pythagorean theorem, a squared plus b squared equals c squared. So the center is going to be opposite signs, because those are, remember, from HIVO, horizontal inside, you do the opposite. So we have -1 and then +2. And then the radius, if you think of this as a squared plus b squared equals c squared, well, c squared equals 16, so the radius is c. So that means each of these things has been squared, so you have to undo it. So you're going to square root, and you get 4. So there's your radius. The next type of question that comes up are these perpendicular or parallel lines that are passing through a specific point. So I'm going to just do perpendicular with you, but if it said parallel, it just means you do the same slope. So just kind of make note of that. Parallel means same slope, and perpendicular means you flip and negate, which really means negative reciprocal slopes is the way we call that. So for this one, which equation represents a line through this point and it's parallel? So if it's parallel, it means it's going to have the same slope and it has to pass through this point. So if I first look at the slope of this old line, that's going to be -2. So the slope of the old line is -2. So that means that the parallel slope is also going to be -2. And then what you do to find the y-intercept is two things. You could graph this point, and then you can count the slope until you get the new y-intercept, or you can find it algebraically, which you should know how to do in case, again, they give you like fractions or something. So to find the y-intercept, this is your x, this is your y. Always just cross out that old y-intercept so you're not tempted to use it. And what you're going to do is you're going to plug into y equals mx plus b. So I'm going to take this, and I'm going to take this, and I'm plugging in. So I have 1 is y, m is -2, x is 3, and I'm solving for b. So I have -6 plus b, add 6 to both sides, so you get 7 equals b. So then the last step here is your equation. So it's your slope that you're going to use and your y-intercept, and you plug those in. So it's going to be y equals negative 2x plus 7. And that's your final answer. The next one here, same idea, but it says you're going to find a line that's perpendicular. So which equation represents a line that's passing through this point and it's perpendicular to this? So the slope of the old line is negative 2 because it's already in y equals mx plus b form. So the perpendicular slope means you need to flip and negate that. Remember, that's over 1. So it's going to be positive 1 over 2. And then when you go to find the y-intercept, same process. Here's your x, here's your y. So you're going to use y equals mx plus b, and you're going to plug those things in. So I'm going to plug this in, and I'm going to plug this in. So it's going to be 1 equals 1/2 for the slope times x, which is 3, plus b. So in this situation, you have fractions, so that's going to be a situation where you wouldn't want to be doing this on a graph. So we have 3 over 2 plus b. Subtract 3 over 2 from both sides, and you get negative 1/2 for b. So again, you wouldn't find that on the graph, which is why you have to know how to do this algebraically. So now taking that and taking this, you can write your equation. It's going to be y equals, the slope is 1/2 x, and then minus 1/2 for the y-intercept. And that's it. And then the next section here is dealing with three-dimensional shapes. So first we start with 2 dimensions, and if we rotate, we go into 3D. So for this first one, you're going to be rotating a rectangle. So anytime you rotate a rectangle, you're going to end up with a cylinder. You should always be getting curved pieces here. You should always end up with circular pieces because you're rotating 360 degrees. So that kind of is a good hint for you that if you take a straight segment and you rotate it 360 degrees, that's going to work as like the radius of your circle. So you'll always end up with, so in this case, if I were to sketch this, I end up with a cylinder. So anytime you take a rectangle, these are usually multiple choice questions. So it should be the second one here. They're all right, meaning they're all straight up and down. Not going to be a rectangular prism because that has lines. An oval cylinder would mean that wouldn't work because that would mean your radius isn't the same to create an oval. And in this case, it's the same that's rotating. And then you're not ever going to have anything that's square. So it's going to be a right circular cylinder. Right just means, again, perpendicular to the base. And then this one, they're doing the opposite. They're giving you the three-dimensional shape, and they're saying, what would you have to start with? So basically, the easiest thing to do is almost just kind of envision this flat. So if you have a line going through the center, and if you look at it flat, see how you have this triangle, and then you have this rectangle? So meaning don't even look at the curved part, because that curved part comes from rotating it. So I have this triangle, and I have this rectangle. So the only one that matches would be this choice right here. Everything else is just slightly off. Like this one has an overhang, so that's why that one wouldn't work. And then the next topic in 3D we also talked about was cross sections that relate to 3D and 2D. So meaning if you slice a three-dimensional shape. So cross sections when you slice a three-dimensional shape. So given a right circular cylinder, it has a radius of 8 and a height of 20. We don't even really care about that. Which of the following choices is not a possible cross section? So thinking about slicing this, if I slice it parallel to the bases, anytime you slice parallel to the base, whatever the base is, that's the shape you're going to have. So if you slice parallel, you're going to get out a circle. So that's definitely always going to work. An oval would be if you sliced kind of at an angle, so meaning something like this, you would get this like oval shape. So that would work as well because it is curved. So that would work. A square you won't be able to get because if you want straight edges, that means you're going to have to slice perpendicular to the base. And that means if you slice perpendicular to the base, it's going to look like this. which is going to be a rectangle. So rectangle works, so square is the one that does not work. So just imagine that was like when we did the Play-Doh and you slice the objects. That's the idea with cross sections. Usually there's a multiple choice question on that as well. And then density and weight problems can occur in the short answer. Sometimes multiple choice questions, but a lot of times in those like 4 and 6 point questions. So density is something that you want to recognize as it has 2 units. So it's going to be a volume per mass. So it's going to be cubic something, so a cubic length per some weight measurement. So that's something that you want to recognize. And usually you're going to be using that if you're trying to find the weight of an object, because in geometry you can calculate the volume, you'll be given the density most of the time, and then you're just going to find the mass. So in this situation it says a kitchen was remodeled and granite countertops were installed. Rectangular island in the kitchen now has granite top measuring 5 feet by 8 feet by 1.2 inches. So right now I have a red flag because my units aren't the same. And then if I look at the density, it says it's grams per cubic feet. So that tells me that I need to get my units into feet, because my weight is going to be grams and my volume is going to be in cubic feet. So that means all these need to be in feet. So that's kind of the first thing I need to worry about before I even continue, is I got to get that 1.2 into feet, because my density is given to me in cubic feet. So let's just take care of that first. So convert inches to feet. So you can, some of you just know how to do this, but the other thing is just think of your conversion. So 1 foot equals 12 inches. So you don't know the number of feet, and you know that you have 1.2 inches. So you just make sure your units are lined up. And then from here, you just cross multiply. You don't really need to carry the units because they're already lined up, so they'll take care of themselves. So it's 12x equals 1.2, and then divide by 12. So essentially, you could have just divided by 12, but you can always do a conversion if you're not sure. So that's going to be 0.1 foot. So really, this turns into 0.1 foot. So then if we continue, it says how much does the granite top on the island weigh in grams? So we're trying to find the weight, which means find the mass. And in grams is good because that's what my density is given to me in. So I don't have to convert anything anymore. I'm good because my volume's in cubic feet, and that's what all my dimensions are. And my weight that I'm trying to find is in grams, and that's what my density is given to me in. So now you can actually start the problem. And if you look at this, so imagine the island here. So it's going to look like a rectangular prism, because it's just a rectangular looking island. And the height or the thickness of the countertop is 0.1 feet. So it's 5 feet here by 8 feet for the island. So if I want to find the weight of it, I have to know the volume because I know the density, and if I use density with the volume, that'll allow me to solve for and find the mass. So the first thing you need to do is you're going to find the volume. Well, the volume of this is just going to be length times width times height. So length is going to be, so it doesn't really matter, just multiply the 3 numbers. Length times, so 5 times 8 times 0.1. So you multiply those are all in feet. So when I'm done, I get 4 cubic feet. Make sure you put your units on that. So there's the volume. So if I want to find the weight, I'm going to use my density triangle here. So density equals mass per volume. So I need to find the mass, which means mass is going to be density times volume. If you cover this up, it means you'd be multiplying. So it's going to be the density, which is 2.7 grams per feet cubed, times the volume, which is 4 cubic feet. So what happens is the cubic feet cancel because one's on top, one's on bottom, and you multiply these numbers. and you get 10.8, and then your units that are left are grams. So there's your weight of the countertop. So that's one basic example. So just finding the weight using density. You're always pretty much going to have to calculate volume, because that's the geometry part of this, is you know how to calculate volume, and then you can use density to find the mass. So let's look at one more example of that type of problem. So for this one, we have 98 cut boulders are being brought in to help prevent further erosion on a portion of this coastline. Each boulder has been roughly cut into a cube, so that's important here. So we're talking about a cube with side lengths that are 0.8 meters. The stone in the boulders has an average density, so again, it tells you the density. Sometimes it won't tell you the density. It might just say it has an average weight of 3,000 kilograms per cubic meters. You have to know based on the units that that's a density. So be careful. Just because it says weight doesn't mean it's not a density. Whatever the units are. If it's just a weight, it would just say kilograms. If it's a density, it's kilograms per cubic something. So in this case, we're in good shape because my dimensions of the cube are in meters, and so is the units here. So if I go ahead and just sketch out this cube to represent one of these boulders. So this is going to be 0.8 meters by 0.8 meters by 0.8 meters. Find the average weight of each boulder in kilograms. Good news, because kilograms, it matches, and my meters and meters match as well. So for part A, it's just going to be what we did on the last problem. So it's just going to be find the volume, length times width times height. I don't have to do any conversions here. So just multiply the 0.8 by itself 3 times, or just cube it, whatever you want to do. And my units on this are going to be cubic meters, so I get 0.512 meters cubed. So there's the volume. So now again, if you think about your density triangle here, density equals mass over volume. That means that for density, it's going to be, or for mass, it's going to be density times volume. So my mass is going to be the density, which is 3,000 kilograms per cubic meters, times the volume, which we just found. And your cubic meters cancel, multiply those numbers out, you get 1,536 units are going to be kilograms. So that's part A. So that's, again, like I said, a typical density problem. That could be like a 2-point question. It could be a multiple choice question. And it could be part of a larger problem. So this problem, there's a part B, which tells us that this could be like a 4-point question, or maybe even a 6-point question. So for part B, now it's talking about a dump truck. Oops, before I move on, this says round to the nearest 10th. I didn't read that. So round to the nearest 10th means you should have 0.0 on here. So it should have 1 decimal place. Again, make sure you're carefully reading your rounding directions, because that's important, so you don't lose a point for that. You'd lose a point if you didn't put a 0.0 at the end, which seems silly, but it would happen. So for part B, a dump truck will carry with a carrying capacity of 28,000 kilograms is used to transport the boulders to the coastline. So the truck can only hold 28,000 kilograms. How many trips will the truck need to make to transport all of the boulders? So basically, we have to transport, each boulder is 1,536 kilograms. We have to transport, if we go back up to the top, 98 boulders. So sometimes it's easy to overlook numbers that are written out in words, but there's 98 boulders. So what we should do is find the total weight. So the weight of all 98 boulders. So we know the weight of one boulder. So just multiply that by 98. So 98 times the weight of one. So we get 150,528 kilograms. So then if the truck can hold 28,000, to figure out the number of truckloads, we'll just divide that out. So we'll take our total weight that we have to transport, and if we are going to fill it up to its max capacity, meaning 28,000, so our total weight that we have to transport divided by the amount you can put in each truckload, you end up with 5.376, which means that it would take you 6 trips, because you can't do it in 5, it would go over. So you would have to do it in 6. So it will take 6 truckloads. And then the last type of problem on this page, so area of a sector, so that you have to know your formula for. Anytime there's usually a multiple choice or a short answer question, so area of a sector, just remember it's what portion of the circle are you dealing with. So it's whatever the central angle is divided by the total number of degrees, so 360 degrees, times the area of a circle, so pi r squared. Pi r squared is the area of a circle. That's given to you on your reference sheet, but you have to be able to come up with this formula. So if you look, the radius of the circle is 9, the central angle is 120. Find the area of the shaded section. So this one's really straightforward. It's just plugging into the formula, but you have to know this formula. So the area of a sector, so it's 120 degrees divided by 360. Again, that should always be in the same term. So if it's in degrees, then it should be in degrees down here. Times pi, radius is 9, and then we just put all of this in our calculator, and we're rounding to the nearest tenth. So we're going to go ahead and enter everything, including pi, and we get 84.8 units on this. We're talking about centimeters, so it's going to be centimeters squared since it's area. And that's it for that one.